The topic of our discussion today is, as you can see, OpenStack for VMware admins. Before we start, please feel free, if we had internet in the room, I would say feel free to share your thoughts or comments on Twitter, Google+, Facebook, whatever you would like. Unfortunately, actually, the internet is not very stable here at the moment. If you want to take pictures, please feel free. And of course, the presentation will be available after the conference itself. So, slide a little bit about myself. My name is Maish. I am, at the moment, a IT architect or a platform architect in Cisco, which was once upon a time, I used to work in NDS, which was acquired about 18 months ago by Cisco, work in Jerusalem. I have a long history with VMware. As you can see, there's 4 different icons. I've been awarded the honorary VMware vExpert award 4 times in a row for contribution to the virtualization world with a blog that I have, through Twitter, through conferences, through all kinds of other things, including also, I was the author or co-author of the VMware vSphere design book from the first edition. And as of late, I actually also participated as one of the technical reviewers for the 2nd edition of the OpenStack Cloud Computing book as well. The quote, which I looked at and tried to find, was Mahatma Gandhi. First they know you, then they laugh at you, and then they fight you, and then you win. So if you take, instead of the you, put OpenStack, you can say first they ignore you because nobody said OpenStack would do anything. And then everybody started to laugh at them because they say, no way this kind of a project can actually do anything because there's so many different directions, so many different people trying to contribute into it. And now everybody's starting to see OpenStack as some kind of a threat or a very big player in the cloud world. Will they win? I don't know, but that was the quote that I found. But why did I actually propose this session, and why did I actually want everybody to come if they could, whatever they would like? But the reason was, there was a lot of people which have perhaps a perception that things are, as I say over here, it's the same thing as VMware. Once you know a platform, you know them all, and information is easy to come by. But slowly but surely, going into all of these things, I found that none of these were true. OpenStack is completely and totally different from anything that VMware does, or way it works. If you want to know how VMware works, you have absolutely no idea how OpenStack works. And of course, information, which I thought would be very simple with our good friend Dr. Google, didn't come out as easy as I thought it would be, because there was not a lot of information out there to show exactly or explain for a person who is a natural VMware admin, which I came from that kind of a background for a good number of years, how that translates into OpenStack. An oxymoron is, as I say, a figure of speech that there's contradictory elements here, because as you can say, there's VMware and there's OpenStack, but they more or less do the same kind of thing. Aren't they the same? Competitors working together, competition, as we heard in the previous talk from this morning. But they're not exactly the same. There are certain elements which are similar, but I wouldn't call VMware or vSphere or vCenter or the vSphere or the vCloud suite even perhaps a complete competitor or an exact product, the same thing as OpenStack is. And over the next couple of points, I would like to go into see exactly how there are differences between them and where some of the similarities are. Here's your typical VMware environment, your standard VMware environment. Before I start, how many of you are VMware admins or have a VMware environment in your organization? How many have an OpenStack environment in their organization? How many have both? Well, it was more or less enough for everybody. Okay. So for those who don't have any kind of VMware environment in your organization, which I think there was very few over here, you have a VMware vCenter server which manages all the hosts and the virtual machines running in your data center, in your clusters, which can be divided up into different kinds of pools or into different kinds of tiers if you would like. And in OpenStack, we have this. And when I first saw this diagram, I said, God help me. Because for an architect, this is something you can understand if you really try and really understand. There are so many arrows going to different places, wherever else it is, what kind of components would. How do I find my hands and legs in something like this? And it's not easy. Seriously not. For an administrator, there's absolutely no way they're going to be able to understand it. So luckily, somebody got the point and understood that for an administrator, you can't give a kind of diagram like that, because he'll say, I don't want to touch this stuff because it's horrible. What am I supposed to do? How am I supposed to follow the arrows? So they put out something like this, which is more like of a logical overview of how OpenStack works. And for OpenStack, we have these different components. We have a dashboard, which is an interface which allows you to interact with your system. It's called Horizon. You have on the left-hand side Neutron, which is a component which manages all your network inside your OpenStack environment, be that IP addresses, DHCP, routers, firewalls, and so on, netting, and all kinds of things like that. You have underneath that, you have Cinder, which is a block storage which allows you to attach volumes to your virtual machines or instances. We'll get to them in a second. You have Nova here in the middle, which is the actual hypervisor that gives the compute services to the virtual machines. You have Glance, which is a component which serves as a repository for all your templates. Swift, which is an object storage, if any of you are aware of something called S3 in Amazon, which allows you to interact with an HTTP interface or REST interface to some kind of a storage somewhere. You don't really care where it is. And you have Keystone, which manages identity and authentication for all of this. So how does this translate into what we have for VMware? The dashboard and identity is more or less, I would say, handled by vCenter. All the authentication and the management of everything is done by vCenter. If you go through one central management interface, you have either through Active Directory, which is interfaced into vCenter, but the main component which does all the authentication of what permissions you're allowed to access, what virtual machines you're allowed to power on, and so on and so forth, is done through vCenter itself. Everything else, except for this, is managed by ESX, the vSphere host. You have network, which is done by the ESX host, the storage for which is connected to the virtual machines. You have the hypervisor itself, and you have some kind of a template repository, which is also on the ESX host or connected to the storage itself. Yes, please.
What about the distributed vSwitch?
Distributed vSwitch is more or less handled also part of logic as in the vCenter and the ESX host itself, but I'm not going to get into the distributed vSwitch at the moment, if you don't mind. Okay. Last but not least is the object storage, which at the moment does not exist whatsoever in VMware. There's no such component which they produce or market to have some kind of object storage for your virtual machines environment itself. If you want, you can put up something else on externally, but there's nothing which VMware gives you. So, differences between OpenStack and VMware. Virtual machines are not called virtual machines, they're called instances. That's the first most important thing that you should understand. You power on instances, you power off instances. Difference between, for example, on virtual machines and OpenStack, you power off an instance, you kill it, and it's deleted completely, you don't have anything left over. Not as in compared, unless you have something connected to a persistent storage, we'll get to that in a second, but in essence, you have a powered on virtual machine, or instance, or a terminated instance, which means everything which was in that operating system, unless you stored it outside of that operating system, like, I don't know if you heard from Kobe, which was from live person was speaking about everything is nothing persistent in the OS, it's gone. All your logs, all your data, whatever else is inside, if you terminate your instance, it's gone. It's not like VMware, which is if you power off a virtual machine until you delete it physically from the data store, it's always there. Custom virtual machines, in other words, I want to define exactly how much resources or how many resources I would like to allocate to my virtual machine. It does not really exist as a function inside OpenStack. In other words, in VMware, you just change your settings of how many disks, how many network cards, how many floppies, or whatever you have. In OpenStack, everything is called a flavor. In other words, you have defined sets of templates of virtual machines which allocate disk, CPU, and RAM, and that is given as an instance. In other words, you want to deploy a virtual machine with X amount of RAM, X amount of CPU, and X amount of disk. You choose one of the flavors and push the operating system, which will give that definition of what those resources are for the virtual machine, for the instance. Images and templates. Templates, we know from VMware world, is some kind of a template or a blueprint which we can pre-configure whichever way we would like. and clone or copy those virtual machines and make that as like a master gold image of ours to deploy the rest of our virtual machines from there. In OpenStack, these are called images. They can be done either from a snapshot or from a physical image on the disk. There are several differences between the way VMware works and the way that OpenStack works. For example, templates or the images in OpenStack are managed by a separate component, completely, not related to anything else, called Glance. In other words, it's a service which has to, when anybody wants to deploy an image, they have to go to Glance, give me the image, and deploy that image to your host. Therefore, as I noted at the bottom over here, every time you deploy a new instance on a new host, then you will need to copy that image to every single one of your hosts in your cluster. Not as compared to what we have in VMware, which has got one central repository on a shared storage or local storage device, and then you only deploy, you copy all the blocks to your new virtual machine, and you power it on. With OpenStack, you copy that template to your new host, and then clone it again to a new instance. So of course, there's a lot of considerations you have to take into account for the amount of time you'll have to deploy, it will take to deploy a new instance, depending if that machine has already been deployed once before on a host or not. VMware has, for storage, you have an option which the disk is usually presented to the virtual machine as a local SCSI device. You can also do IDE. I never understand why you would ever want to do that, but you can also do IDE if you want as your device. Whatever is written in the information is written to a disk on the back end via the central storage or local disk, and that disk, that information stays there until you physically delete the file on the storage device as physically delete the virtual disk itself. Can be central storage through NFS or VMFS, either iSCSI, SAN, or a local disk. If you would like it, will be for your storage devices. On OpenStack, it's also presented as a local SCSI device, or virtual SCSI device. But now you're going to start hearing all kinds of terms called, like, for example, ephemeral storage. What is ephemeral storage? Ephemeral storage is what I said before. Machine powers on, everything is there, you power it off, terminate it, everything goes poof. Nothing is persistent. In this case, nothing is persistent. So anything which is written to that operating system won't survive. Here's another option, for example, block storage, where you can attach physical volumes, usually iSCSI volumes, to an instance as a second disk. For example, your SDA is your ephemeral storage with only the operating system files. You want to store data which will be persistent. You have to attach an external volume. When you terminate this instance, the volume will stay, the actual instance and everything inside it will be gone. Yeah.
That's like using an RDM in vSphere.
Similar to using an RDM in vSphere, correct. And of course, in OpenStack, there's the object storage, which is Swift, which there is absolutely nothing which exists like that in Vmware Environment today. High availability, migration, and so on and so forth. We have vMotion, Storage vMotion, SDRS, VMware HA, App HA, VASA, VAI, and shared disks. These are all things which we use as VMware admins today, usually if you have an Enterprise Plus license, depending on what. But we use these things. vMotion is to migrate a virtual machine from one physical host to another. Using shared disk, Storage vMotion is to move from one disk array to another disk array while the machine is running or powered off. VMware HA is a mechanism which is employed or in use by VMware to detect the failure of a physical host, and all the virtual machines on that host, depending on your settings, will power on somewhere else in your cluster within 2 minutes. And everything will be back up and running the way it was. App HA is something which allows you to detect failures in the operating system, either the operating system crashed, blue screen, kernel panic, and as of late with the latest version 5.5, you can also, for specific services, restart the service itself as well, if you need to. VASA VAI are storage, are directives which the storage array presents to the hypervisor. In other words, I have the option of saying I am an EMC array with this amount of disks sitting at this RAID level. You can do with it what you would like. VMware knows how to use those to create storage profiles, and including also VAI, which allows several commands and operations to be offloaded from the hypervisor to do those work, to the storage array. In other words, for example, if any of you use a NetApp for a flex clone to copy a virtual machine, it's almost instantaneous. You don't have to do anything over the network. It's done like this, really very, very, very quickly. That's something, that's kind of an example for VAI. OpenStack has line migration. Line migration is similar to, I don't know if any of you know what used to be Hyper-V version 1, that you have the option of moving over a virtual machine, pausing it, completing the final copy, and then powering it back on. There is an option like that, not very well used. That is why a lot of people always say OpenStack, at least for virtual machines running in OpenStack, do not rely whatsoever on the underlying hypervisor. You have to make sure that your application running on your instance is redundant in its own way. That you can lose a host, or you can lose a server physically, whatever else it is, as long as you have a clustered application that will be able to suffice. DRS, we'll start with DRS. DRS is a load balancing mechanism, distributed resource scheduler in VMware, which load balances your virtual machines according to load on your cluster. And it does it once every 30 minutes, I think, if I remember correctly, by default. Nova Scheduler does something similar, but it is slightly different. It's not a dynamic thing. In other words, when you power on an instance, it will go to Nova Scheduler to say where is my best placed location to be, and it will move it there, and it will stay there until you terminate the instance. Always. It will never ever move from where it was once powered on. There's no dynamic load balancing between, in other words, if one of your hosts gets very, very, very loaded because of something else, everything on that host will stay there and suffer. It won't move automatically over to another location. The vSwitch and distributed vSwitch, we have Open vSwitch and Neutron components in OpenStack. With the distributed vSwitch is a centrally managed virtual switch, which is logically located in vCenter, physically located in a small file, an actual ESX host per host on the cluster. Open vSwitch does more or less the same thing.
It's not distributed, right?
Sorry, the Open vSwitch is a distributed vSwitch. Distributed switch on the network. You only configure it once in one central location on the network node.
But Open vSwitch is in each host.
It resides in each host.
It's Nova Compute.
It's part of the Nova network. I mean the Neutron component, which does that.
Okay. But who configures each Open vSwitch in every host?
You configure it through the
Once,
correct.
Okay.
Okay. Now, as a personal pet peeve, or whatever I would like to call it, the most difficult thing that I ever found to understand in a VMware environment, I don't know if you ever got to it, was vCloud networking. How that works, what is the difference of organizational networks, how the NAT works, how DHCP works. It's extremely, extremely complicated. When I looked into how Neutron works, 15 times more. Because it's a completely different mindset than what as a VMware admin you're used to. It's completely in software, which is, I think, one of the best advantages in OpenStack, and also one of the worst disadvantages in OpenStack, that everything is done with software. Storage is done with software, hypervisor, network, everything is done with software. There's a lot of advantages and there's a lot of disadvantages. I'm not going to go into that at the moment. For now, what we have over here. Redundancy should be done at all of the levels. In other words, by default, you have one Cinder component, one Swift, one Neutron, one so on and so forth and so forth. One of them dies, your service is gone. You can't provision new networks, you can't provision new virtual machines, you can't get a virtual machine instance because glance is down, you can't do it. So in a highly available environment, for example, if you go into vCenter and vCenter dies, correct, you can't provision a new virtual machine through vCenter. And if you're using a distributed virtual switch, you're going to have a problem connecting to your ESX host and powering on a new VM and connecting it to the correct network. That is true. But also over here, there is a single point of failure of some sort, and it has to be done with some kind of a clustering mechanism, which is, as far as I know, and I'm not an OpenStack expert, it's not built in. You have to use external applications or external solutions, for example, Pacemaker or Galera for MySQL to make it MySQL highly available, or one of your services, for example, Nova Computer, Nova API has to be highly available, you have to use an external solution as a clustering mechanism. Potential bottleneck in a single point of failure. We are used to, as a VMware admin, that all the network connectivity coming from an ESX host goes directly from the ESX host to the network cable out to the router, no matter where it goes. Anything which is not on the same physical port group on an ESX host goes out of the network and back in. In this case, for OpenStack, there are two different models. For example, the first one is internal traffic between virtual machines or instances. If you're using what they call GRE tunneling, which connects each physical host with a logical network pipe between each one of these hosts, all the traffic goes directly between host to host, doesn't go out onto a single external router. If you use it, but anything which goes out of your OpenStack cloud has to go through what is called a network node. That is the one which manages all the Open vSwitch and all the rules and everything else. That means anything coming from the internet always comes into here and then goes to the correct node. Anything coming from here to the internet, out to the internet, does the same thing. Always goes to the network node and comes out. That is a huge potential single point of failure and bottleneck. In other words, your network node has to have enough bandwidth to handle traffic from your whole OpenStack environment if it's the only one, and of course it has to be highly available, because if your network node goes down, you have no external connectivity into your OpenStack environment whatsoever. A few links which might help, and I've got one more slide I think after this, I'm not sure. A few links which might help for people like us, VMware admins, if you want. There's a gentleman by the name of Kenneth Huey, who is a rack-space architect, who had started a nice OpenStack XXX for vSphere admins. A very good blog post series. If you look him up on the internet, you'll find very, very detailed, good information of how to perhaps understand more about how, for example, how the resource scheduler works in Nova and all kinds of other things as well. VMware released not so long ago a appliance called VOVA, VMware OpenStack Virtual Appliance, and I'm sure the people which are from VMware will be happy to explain to you a little bit more about it over here later in the session upstairs. It allows you to test and see how VMware or vSphere integrates within OpenStack itself, how you can, there's a plugin for the web client and so on and so forth, a huge amount of things as well. In the last OpenStack event in Hong Kong, there was a talk by Kenneth Huey and another gentleman by the name of Scott Lowe, who wrote the book with me for vSphere, of exactly explaining OpenStack to VMware administrators, which a good part of this presentation is based on. My blog also has some information if you're interested in reading. And any questions?
So what I need to choose? VMware or OpenStack?
It depends on what you need it for. As a good IT person, I'll always say it depends.
I'll tell you what I get from your presentation. You get that OpenStack is not mature, is immature totally. Okay, it's very risky. And VMware is very good, but very expensive, as I know.
Correct.
So, what should I choose?
Whatever is correct for your environment. For example, you'll hear a lot of people.
I have no money.
So if you have no money, use Ubuntu with KVM and do OpenStack on a PC white box at home. But that's not going to be able to run your development environment in your organization. So what I personally am hearing from a lot of people, and also at this conference today, is OpenStack is very, very good for development environment. It makes IT's life a lot easier because they can just say, okay, here's your OpenStack, you manage it, you power on your virtual machines, you have a box with that amount of resources, you start using too much, everything which is yours starts to suffer, but you manage it, I don't care.
This is the basic case for VMware, right? So I can provision for some unit specific capacity in a very low cost. This is the basic VMware value. So there is a very aggressive competition between OpenStack to VMware, and OpenStack is better because it's just cost efficiency.
The problem is the fact that there's additional functionality in OpenStack itself, which allows more, like for example, a self-provisioning mechanism to the users that they can do what they would like. By default in VMware, in vCenter and ESXi, that doesn't exist. You want to go to that, you have to go to vCloud, and then you start creating, which again entails more and more cost per virtual machine that you go for. Any other questions?
What's different between UCS Director and OpenStack in this case?
UCS Director is a product, and I work for Cisco, as I said, and also over here, Dennis does work for Cisco. So UCS Director is a product which allows you to provision through a workflow engine a whole stack of hardware. In other words, UCS Director, for example, can configure your NetApp storage, your EMC storage, provision all the LANs, configure your UCS chassis, configure all the network cards, power everything on, install ESX on it, and then start deploying all the operating systems on top. It's a whole workflow engine for the whole stack. OpenStack,
It's not Cisco.
it used to be Cloudvia, which was acquired by Cisco, is now renamed and rebranded called UCS Director. But it is for the whole platform. OpenStack only starts from when you have the OpenStack environment up and above. Yeah.
How do you edit ESX as compute node for OpenStack? I know there are a couple of drivers.
Okay, there are two different libraries that you can add into VMware, into ESX. You can either create a library, there is a library which directly talks only to the ESXi host, and there's another library which talks to your vCenter. Up until Havana, there was a huge number of limitations which were present in the fact, for example, you could only wait one cluster. When you added vCenter, it would only see the first data store, which was on the ESX host. There was a huge number of limitations, which have mostly been addressed in the Havana release. But there are drivers you have to add it into. Exactly the process I can't detail over here, but it is possible. And the documentation is relatively simple as well. Okay. Thank you very much.